concerns and considerations. It's the important things that it didn't really fit elsewhere. And starting us off is another longtime colleague and friend, Brad Udall. Brad's currently a senior water and climate research scientist at CSU. There's several interesting things on his resume, including having served as director here at the Getches Wilkinson Center. There's been several references today to some of his recent work, which ironically he's only partially going to mention. He's going to talk about a larger suite of work, so that will be interesting. And everyone's been asking me why I stopped playing the Google game, so you can Google Brad Udall's name, and if you do that, you will find all sorts of interesting things on Brad. But what it really reminds you of, what an interesting political family he's from. His Uncle Stuart was certainly, as Secretary of Interior, was involved in a lot of key Colorado River decisions. His brother was recently a senator here in Colorado. And of course, his dad, Mo, ran for president, among other things, and was represented Arizona in Congress for 30 years, is that right? 30 years, wow. And ran for president. Had he won, Brad, you could have been the Ivanka Trump of your generation. I better stop there, Brad.
So good morning, everyone. It's a total pleasure to be back here where I worked for about a year. And the Getches Wilkinson Center is a terrific entity. And my hat's off to David Getches and Charles Wilkinson and this entire university that supports what Doug and others do here. So Doug, you've heard the expression forewarned is forearmed, right? And you've also heard the expression that's what's sauce for the goose is sauce for the gander. So two can play this game. American writer and actor who co-founded the National Lampoon in 1970. That's the good news. Bad news is you died in 1980.
In Hawaii, it must have been a drug overdose. Must have been.
All right, so who here knows the milestone, the climate milestone that we passed last year in 2016? 400 parts per million, right? 400 parts per million. We are not going back on that. It will be perhaps 10,000 years before Earth sees 400 parts per million, because it takes a long time to wash CO2 out of the atmosphere. And so there's your graph out of NOAA. Chris Mooney did the story on it. Washington Post, some of the best coverage right now going on climate change. Jeff Bezos is doing it right here and funding some great journalists on this. So how far back do you have to go to get to 400 parts per million? You get to go to the Pliocene, 2.6 to 5.3 million years ago, and even Chuck Howe was not alive in the Pliocene. Indeed, modern humans did not walk the planet at that time, right? Modern humans arise about 200,000 years ago, so we're not even around. And that woolly creature you see there is in fact not a woolly mammoth that we associate with the Pliocene, the cold era that came after the Pliocene. That's another woolly creature living in a savanna environment. It's 2 to 3 C warmer than it is now at that time. The Arctic's 10 to 20 C warmer, giving rise to this Arctic amplification that we see that's underway. And sea level is 15 meters, 45 feet to 25 meters higher, which means both Greenland and West Antarctica are gone, and probably some contribution from East Antarctica as well. 400 parts per million, we crossed that last year. One of the things that we cannot do in this current climate is predict with accuracy what the future will bring with respect to the water cycle. And as much as I love Terry Fulp and his charts that show the predictions of dire shortage in the lower basin, and as much as I totally respect the people that work for him, Carly Jurlis here and Alan Butler and Ken Nowak, Jim Prairie, our ability to be able to characterize this risk right now is quite poor. This is a trace out of the 2007 interim guidelines modeling that Interior did. And in green there is mead. And for 25 years, it bounces on the bottom of the reservoir there. And look at Powell, it's slightly better. I mean, and look at the curveball that comes in 2024 with Powell. I mean, it's like, oh yeah, we're out of this. That big ramp up there. And then it goes away and hangs out below the power pool for another 20 some odd years. We cannot adequately characterize this risk. You all in this room have heard the term stationarity is dead, right? That the past is no longer a guide to the future. Black line is snowpack in the Colorado River Basin in the state of Colorado this year. March of this year was 8.8 Fahrenheit warmer than normal in this state. That's the #1 month out of 123 Marches in our record. And you can see what happened there to the snowpack. It actually peaked in March. 8.8 Fahrenheit. I mean, in degrees C, that number is actually large. It's 5C. Oftentimes when I talk about temperatures that I worry about, you know, it's 1 or 2 or 3 Fahrenheit too warm. 9 Fahrenheit. And the lower basin before this was licking its chops. They thought they were going to see a release, the end all releases out of Powell that would, you know, up the contents of Lake Mead, right? And it caused Mr. Bushotsky a little problem down there in his negotiations. On March 1, we had 145% of normal forecast, and we're now at 116%. It's quite a drop. And a chunk of that is due to temperature, right? So I want to go over Dennis Lettenmeyer's findings yesterday quickly because it underscores the study that you've heard a lot talked about today. And I'm actually not going to talk about my study very much with Overpeck. But this is independent confirmation of our results. And what Dennis said was that Colorado River Basin's ground zero for warming, and he had two numbers, a winter and a summer one, but call it 1.6 C warming. He said California has about a third to half of our trend. What he then did was detrend historic temperatures and run it through a model. And what he found out is when you detrend those temperatures, you can explain 50 to 60% of the downward trend in terms of temperature, which is actually a more extreme number than came out of the study that Overpeck and I did. And he put up a slide that looked like this. There might have been the same one. And those of you who are good at geography, what areas in the basin are losing water here? They're all in this state. The darkest one there is the main stem of the Colorado, the most productive region. North of that's the Yampa. The whites actually doesn't lose very much. The Gunnison is in that same not very good color, but it's the Uintas in Wyoming that actually do pretty good. And I'm going to come back to this in just a couple of slides. When I mentioned this to Ann Castle yesterday, she said, well, that kind of looks like self-curtailment by Colorado in the future. Because if you think about it, all the infrastructure in the upper basin, it's in this state. And to some degree in Utah, it's not up there in Wyoming. So here's the image from our study. And I want to mention one thing. I want to throw one rock at this study, lest people misunderstand it. And the rock I'll throw at it is that the numbers you hear are temperature-induced declines, net of what happens to precipitation. So it's what temperature alone would do to the flows. And on our go-to image, which isn't this one that actually has the reductions, on the right side of that graph is the precipitation that increase that you would need to wash out our declines. And at mid-century, you need an 8% increase in precipitation year in, year out to wash out the 20% decline, we say 8%. Doesn't sound like very much. Any guesses what the wettest decade in the 1980s generated in terms of increases in precipitation? That was the decade where we almost lost a spillway at Glen Canyon Dam. 8%. End of century, it's more like 14%. These are actually huge precipitation increases. They're not small. They're actually huge, and they have to occur year in, year out to wash out these temperature-induced declines. And the other thing I'll talk about in a slide or two is the increased risk of mega drought and the potential to have these very long periods of dryness, and how that risk is going up. All right, I want to talk about snowpack because that's what Doug wanted me to talk about, and I'm going to talk about it west-wide because you can bet if Jeff Keitlinger's State Water Project snowpack goes away, he's going to be looking a lot more carefully at the snowpack in the Colorado River Basin. And 2 years ago, in 2015, in that meadow where Jerry Brown is standing there in the bottom, there's 5 feet of snow normally, and there was zip. 5% of normal snowpack that year. Despite precipitation that frankly wasn't that bad, it was 40 to 90% of normal in the Sierra. But what was different that year is that the average winter temperatures were above 32 Fahrenheit. Some scientists put this at a 500-year return period, but that's bogus. It might have been 500 years looking backwards. It's not 500 years going forward. That I can guarantee you. I mean, the potential for this to occur in the Sierra as this century unfolds is enormous. It will happen again. Here's a study Phil Mote did, recently published. And what he says, and gets to our point, key points in the 2012-2015 West Coast drought, unusually high temperatures played a prominent role in reducing snow accumulation and causing drought in much of the westernmost U.S., April snowpack was at its lowest ever in 2015. That image there is snow courses that go back to at least 1976. And every black dot on there, that indicates a snow course that had the lowest ever recorded snow amount. I'll note Heidi Collins on that paper as well, and Dennis Lettenmeyer. You know, it occurred to me last night, when you do snow research and look in the literature right now, anything that has snow or snowpack on it has Dennis's name, and I swear he's trademarked it. So that literally, if somebody wants to do a paper on snow or snowpack, they have to go to Dennis. Well, here's a study by Michael Mann and Peter Glick in California. In the upper left quadrant, there is dry and hot. You can see 2014. These are a 3-year period, wet and hot on the right, dry and cold on the left, wet and cold. And I'm going to show you now where the 20th century numbers come from.
'21st century.
21st century. Here's a brand new study out of Flavio Lerner. Dagmar Llewellyn is reclamation, Doug Blatchford's reclamation, Eugene Wall's a paleoclimatologist. And what they say is the decreasing runoff efficiency trend from 1986 to 2015 in the upper Rio Grande Basin's unprecedented in the last 445 years. And the runoff ratio is the amount of runoff you get for the precipitation that's there. So very low runoff ratios are 2.5 to 3 times more likely when temperatures are above normal than when they're below normal. And their image there, we've now inverted these sectors. So the upper left is wet and cold, lower right is warm and dry. And then the color bar there tells you where runoff efficiencies are low in red and high in blue. And if you look at this, those low runoff efficiencies are all on the, well, they're not all on the warm side, but they cluster on the warm side, right? Both wet and dry. And they say that this runoff sensitivity to temperature implies further declines. Should warming continue? I mean, if I have a complaint about this, should warming continue? We know it's going to continue. All right, I showed you that pattern before off of Dennis's study of where it wets and where it dries. And first caveat, these climate models with regard to north-south, exactly what gets wet and what gets dry, I'd be suspicious about, but the pattern is what's important here. And this is a 2016 study out of Jessica Ayers and Ficklin, Irish Stewart, some well-known folks in the Colorado River Basin. And using the latest set of models, the wet areas are the Wind Rivers and the Uintas, and the dry, all of Colorado. Soil moisture. This study just came out April 18, 2017. Large near-term projected snowpack loss over the western United States. Nice title, eh? Observations and reanalysis indicate that between 1980s and 2000s, there was a 10% loss in the snowpack. Here we show that this loss is consistent from the results of a larger ensemble of climate simulations forced with natural and anthropogenic changes, but is inconsistent with simulations forced by natural changes alone. So it's climate change that's causing this. A further loss of up to 60% is projected within the next 30 years. Mostly maritime areas, right? California and the Pacific Northwest, especially at risk because their temperatures are warm already. It's easy to cross that 32 Fahrenheit barrier. This is a piece by Connie Woodhouse last year, increasing influence of air temperature on upper Colorado River stream flow. And their key points are when upper Colorado River Basin flow departs from precipitation or temperature is a major forcing. Since 1988, flows have often been less than expected given winter precip. So what they've done is color code all these years. You got 1900 to 2000, and there are two lines on there. The dotted is precipitation, and the dark black one is flow. And you can see, so the blue and green lines are where you get more runoff than you would expect given the precipitation. And the orange and pink ones are where you get less runoff given the expected precipitation. What do you notice about the pink and orange colors? Where do they cluster? Bob Adler's pointing to the right. They cluster in this center. And final bullet, warm temperatures exacerbated modest precipitation deficits in the 20,000s. That's Peck and my complaint. So what is it about these temperatures that cause decreases in runoff, right? You have a longer growing season, it's hotter, so plants are using more. You've got more evaporation from water bodies and soils. You have a significantly increased atmospheric demand for moisture. But in our paper, we actually didn't put this. In fact, it didn't really even occur to us. So this is by Roger Bales at UC Irvine. Mountain runoff vulnerability to increased evapotranspiration with vegetation expansion. They don't get an A for explaining what this is all about, but what they're saying is that vegetation will move upslope in the Sierras significantly, 2,000 feet as it warms, and as that vegetation goes upslope, it actually will use more water. And that's what their chart shows there. The red line is evapotranspiration on the vertical axis, elevation on the bottom. The red line's current, the different greenhouse gas emission scenarios, and you can see evapotranspiration goes up the elevation band as it warms. I mentioned the mega drought stuff, which Toby Alt and Ben Cook and others have been working on. And this is a paper that came out in 2015 that basically says megadrought risk in the latter part of the 20th century was about 10% in the western U.S., southwest U.S. But by the end of the century, it's 80%. Megadroughts being droughts, say 20 or 30 or even 40 years long. And there's pretty good evidence that our current version of climate models don't actually model these things very well. So this is my shirt from the Climate March. It's actually mine. And there are 5 points that the climate science has been making for years, right? It's warming. I mean, we are so sure about this, and that the records, you cannot dispute this warmth. It's everywhere right now. It's us. Experts agree. It's bad, and we can fix it, actually. We have the tools to fix it. Mike Cohen yesterday had a nice slide with his hope, right? He had a bunch of stuff on there, and I don't quite have as good a slide as he does. But let me just point this out to you in the hope factor. So this just happened down in Tucson. Tucson Electric Power is going to buy a whole bunch of photovoltaics for 3 cents per kilowatt hour. Just a couple of years ago, it was 6 cents. The rundown in renewable prices is historic in both wind and PVs. I mean, it's unbelievable what's going on here. Were this building further away, I would have driven my $18,000 Nissan electric Leaf here today, but I rode my bike instead. We have the way to do generation of power. We have transportation very, very close to being able to do what we need to do. Getting the built environment to where we need to go is a little tougher. Some of the airplane transportation a little tougher, long haul train a little tougher, but we've got most of what we need to do. We just lack the will. So let me conclude. Our ability to characterize system breaking and system challenging events is poor. We shouldn't fool ourselves about this. I mean, it's good to have these charts that show risk of shortages and the like, but we need to keep in mind that those numbers behind them, not so great. The risk of these events has never been higher, and it increases as it warms. I'm really glad that the Colorado River Basin is not the Pacific Northwest. It's colder here. We're likely to hold this snow longer. If you like to ski, you're living in the right state. And finally, let me just say, and given my political background and family's background, I am not afraid to wade in this. Most scientists are, and I will not disparage them. But when you study this issue as I have for the last 15 years, and the science gets more compelling and more scary by the day, to not speak out about it is a dereliction of duty. These greenhouse gases, they all gotta go. This petroleum and fossil fuel industry that has done so much for us and so much for humanity over the last 100+ years ultimately has to go away. It's as simple as that. And the sooner it goes away, the better for all of us and for generations that come. And it's everybody's responsibility to get this done. And I'll end right there. Thank you all.
Great job. Awesome.
Thanks, Brad. As usual, we'll wait to the end for questions. I should tell the panelists that what's on the screen, it should also be on these tablets on the table that you can grab and look at if that's easier. Although vision has to be better than mine to use those. I know Brad always has a stack of science papers on his desk that he's working through, and I think it was Wednesday when I saw him, and I basically said, "What's new?" And he said, "There's a lot new and none of it's good." And now I know exactly what he was talking about. All right, moving on. Next up is Jack Schmidt, who's a professor and director of the Center for Colorado River Studies at Utah State University. Until 2014, he was also chief of the USGS Grand Canyon Monitoring and Research Center. And like Brad, Jack has done some research lately that has gotten a lot of attention. His analysis of Lake Powell and Phil Mead First and that sort of thing. And he's going to talk about some of that work. He presented that work just this week to the Upper Colorado River Commission. And so I'm thrilled that he made the trek down here to join us today. Jack's a colleague, a friend, a great scientist, but as Jack will tell you, he has little sense of time. So Jack, I'm going to warn you right now, I'm going to sit in the front row and 20.
There's a zero. There's the time.
No, there's not there. When you're out of time, I'm going to tell you.
Thank you. Okay. All right. Let me move fast. Much of what I'm going to talk about today comes out of a report which I did analyzing some of the technical issues associated with the Phil Mead First proposal. Easiest way to access this report is to Google Center for Colorado River Studies. It'll bring you to this website where you can download this page. The Colorado River cuts through the southern Colorado Plateau between the confluence of the Grand River and the Green River in Canyonlands National Park, and where it exits the plateau and the Grand Wash Cliffs. Approximately half of this length of channel has been converted into the two largest reservoirs in the United States. There are 15 miles of remaining river in Cataract Canyon, and then there's a large scenic ditch that connects Lake Powell and Lake Mead. I want to just give a little bit of context before I go into the Phil Mead First analysis. This is how I think about the major changes that are and impacts caused by large reservoir construction. And those impacts are due to a continuum of changes. Some of the changes are simply caused by the sheer decision of society to build the dam. And at the other end of the continuum are how those reservoirs are operated on a day-to-day basis. The most obvious impacts of just building a large dam is the complete trapping of incoming sediment. At the other end of the continuum is the operational and intentional decision to build or to produce hydropower. And therefore, when we talk about mitigating the adverse impacts to downstream river ecosystems of building large dams, we really want to think about a continuum of what we do. And at the one end is the reduction and change in hydro peaking. At the other end are things that could be done or have been done somewhere in the world, sediment bypass. On the Elwha River, removing the dam, right? There's a big continuum between the two. In the middle are temperature and some flow regime changes. In the Colorado River system to date, we live in this world. Hydropower is the easy whipping boy of what we change on the river to increase downstream or to mitigate downstream adverse impacts. That's the one that always gets changed. Lately, we've instituted controlled floods in Grand Canyon. Below Flaming Gorge, the temperature regime has been changed. In a few cases, at least certainly at Flaming Gorge, the seasonality of changes, of releases has been changed. So I want to jump to a technical analysis of the complete other end of that spectrum. This idea has been around for 10 or 15 years. I was motivated to undertake what I did because, frankly, I was just really pissed by this book. And I was motivated by the ProPublica articles. And I was motivated primarily by the fact that there was just a dearth of technical discussion about the proposals. It was just a discussion of the right thing to do. It was a no-brainer. It's what we ought to do. But there were no numbers that anybody ever talked about. And as a guy back at a university after doing what I did for USGS and Interior, I guess I was just trying to be relevant. So I decided to work on this. This analysis that I did was not funded by anybody, or nobody asked me to do it. A lot of people told me I was crazy to waste my time doing it. The two things that I want to point out and talk about is that the proposal asserts that it would save 300,000 to 600,000 acre-feet a year. That's a big number. And the other point is that it would restore a natural flow regime to the Grand Canyon, natural sediment regime. And in fact, the adverse downstream impacts of Lake Powell would disappear. The proposal is to gradually reduce storage in Lake Powell, first to minimum power pool, then to dead pool, and then let it rip with redrilling the diversion tunnels around the dam. Now, one thing you can think about as I talk about this is that, okay, this is a proposal to intentionally institute these plans. Brad's talk says that some of this may be forced on us, and so we might want to think about this just because it's not because it's intentional, but because this is a world we may have to think about. So let's talk about the purported savings of water. Now, what the Glen Canyon Institute asserted was that to preferentially store water in Lake Mead, they acknowledged that there would be greater evaporation losses in Powell because, after all, storing water in Lake Mead, that there's more evaporation there. But that would be offset by the tremendous savings because all of the water lost into the Navajo sandstone would no longer be lost. So even the Glen Canyon Institute acknowledged that evaporation losses would be greater if we stored water in Lake Mead. What did I find? All a metadata analysis. First off, the idea that evaporation is more in Lake Mead than in Lake Powell goes all the way back to the earliest studies, which we have national level maps of where is evaporation the greatest based on pan evaporation data throughout the United States. And Lake Mead evaporation is substantially more than Lake Powell. The Bureau of Reclamation funds the U.S. Geological Survey to use the state of the science as we now have it to measure evaporation rates from Lake Mead using the eddy covariance method. Now, Dennis Lettenmeyer has cautioned me that as with all elements of science, there is uncertainty, but nevertheless, this is the state of the science. These are the monthly evaporation rates. You can see they change fourfold between winter and summer. You can see that the month of greatest evaporation is different. It's primarily August, but not necessarily August. Has to do with the wind, the cloud cover, the temperature of the water. And you can see that the evaporation is different from year to year. I multiplied those rates by the surface area of Lake Mead in each of those months to calculate the monthly evaporation rate. And using those data, the evaporation rates are between 500,000 acre feet, 520,000 acre feet, and 590. So 500 to 600,000 acre feet a year. Now, something I just learned, just because I decided to do it, so I'll add this. I looked into 24-month studies. What are the numbers that we use in planning and understanding the Colorado River system as reported in the 24-month studies? Those numbers are in red. Those numbers are based on evaporation rates that were derived from studies published in 1958 by the USGS in a professional paper called Water Loss Studies on Lake Mead. Those evaporation rates are the same month after month, or year after year. So the shape of these red curves is the same in every year, with August always being the month of most evaporation. But the reason they have different magnitudes is different surface areas for Lake Mead. Those numbers are as much as 15% greater evaporation than is derived from the USGS measurements. So it could be that the evaporation rates based on the state of the science numbers at Lake Mead are slightly less than we use in the CRSS planning system. One of the biggest revelations that I found was that there have been no measurements of evaporation at Lake Powell since the mid-1970s, well before Lake Powell ever filled. And those numbers are the basis for the evaporation calculations at Lake Powell. But if you look in the 24-month study, the numbers are only 4 feet per year. Why? Because by convention, the numbers that are reported for administrative purposes are what are called net evaporation, which is the true evaporation from Lake Powell minus this number, which is the evaporation that would have occurred from the river in the riparian zone if the reservoir weren't there. But when you look at the column and the data, the number that's there, it says evaporation. But it's not actually evaporation, it's net evaporation. And in fact, the number that's reported is typically 25 to 30% less than what it really would be. So the mindset we all have is that Lake Powell evaporation is a whole lot less than it is from the data. So if you calculate the evaporation rates month by month for Powell and Meade for the most recent studies that have been done, in red is Lake Meade and in blue is Lake Powell. Now, this is admittedly mixing apples and oranges. Eddy covariance measurements made today at Meade, old numbers, 40-year-old numbers, but that's the most recent there is at Powell. The error bars are the natural variability from year to year, but the perspective based on the numbers we have available right now is that the evaporation rates are not that different. For the same amount of water stored in the reservoir, the surface area of Lake Meade, Lake Powell, is more than the surface area of Lake Powell. So you can see where this is going. A little bit less evaporation rate from Powell multiplied by a little bit more surface area. Guess what that means? Essentially, it's a wash. So I ran the numbers. When the system is really in trouble and there's only 7.5 million acre-feet of storage in either reservoir under an equalization scenario, we evaporate somewhere between 450,000 acre-feet at either reservoir. The numbers are about the same. So in terms of evaporation, this is a graph in which this means both reservoirs are dead empty. This means one, they're both plumb full. They're now about 50% full right now. The surface area of the reservoirs is more if you equally store the contents than if you preferentially store them in Meade. For that matter, it would be the same if you preferentially stored them in Powell. You multiply these numbers under the Phil Meade first number, and you basically have to conclude that given the natural range of variability, it doesn't actually increase evaporation if you preferentially store water in Meade. Second piece, but there's going to be this tremendous loss of water into the Navajo sandstone. It turns out that in 1986, the USGS published groundwater modeling studies. And yet when I stumbled on this, the crazy thing is, for all the debate about this topic and the assertions by GCI, nobody in any agency ever has quoted these studies. I think it's because they were published in 1986 and the problem in the basin was too much water, not too little water, and so these studies were lost. Whatever the case, groundwater flows towards Lake Powell. This is a map of groundwater flow directions near the dam and Waweep before Glen Canyon Dam existed. Groundwater modeling, we can talk about the details of this and uncertainties, but what I want to show is the groundwater models predicted a perturbation in the flow field where reservoir water goes around the dam and re-enters the river upstream from Lee's Ferry. That is known to the Upper Basin Commission, and the Upper Basin Commission has funded studies by the USGS to quantify this amount. In fact, in a 4-year study in the early part of this century, 400,000 acre-feet of water in 4 years was the amount of increase. Okay, so this is, I'm getting it, I can tell Doug's body language. All right, so this is, this is a good thing. So this is a way to think about groundwater in Lake Powell. There's no evidence in any study that water just leaves a reservoir and disappears, just disappears anywhere. There have been no studies modeling and predicting groundwater conditions south of the reservoir heading towards Black Mesa. We don't know that. But if you just look at the available data, groundwater flows towards a reservoir. When the reservoir fills, you get some short-term storage here. This is what reclamation considers bank storage that is exchanged back and forth as a reservoir goes up and down. But every time the reservoir fills, there is this inexorable filling of this triangle of water so that you're overall reducing the slope of the groundwater system. This water would come back out if Lake Powell disappeared, but it would come back over centuries, not over years. And the rates of movement of water from the reservoir into the groundwater system have been estimated by a number of studies. So let's just pretend that the enviros are wackos and they produce data we are not going to use. And let's just use the data of reclamation in the USGS. Caltech and the USGS. The loss rates out of the reservoir were very high when Powell filled, 700,000 acre feet a year. Reclamation was worried. There are memos that document that. But the point is, after that period of initial adjustment, the long-term projected rates, if Powell was full, would be on the order of 50,000 acre feet a year to 30,000 acre feet a year. That's about 10% of the numbers estimated by GCI. The reason for that, I don't have time to go into here. But my numbers are simply the numbers of the USGS. All right, let me move quickly then. What would Lake Powell look like if it were partially drained? Or you can say, what is Lake Powell going to look like if it goes to minimum power pool or dead pool, whether we like it or not? In red is the reservoir at minimum power pool. Dark blue is at dead pool. There's still going to be a reservoir there, a long, snaky, little, thin reservoir. In fact, and what we know is there are going to be big waterfalls that are going to have to be dealt with at the head ends, just like we also have in Lake Mead, because the river now flows over bedrock, and we're going to have to deal with fish migration, navigation, and issues there. What about sediment? That's Height Arena during the last low stand in 2004. These are surveys done by Duke University and the Bureau of Reclamation. Up the Colorado River arm in black is the bed of the river, and in color is the amount of sediment that forms the delta up by height at the head of Lake Powell, and this is up the San Juan arm. The vertical exaggeration is tremendous, okay? But in green is the amount of sediment that has already accumulated in Powell. What happens if the reservoir goes to minimum power pool? Then the river begins to saw through these deltas and build new deltas here, such that the water releases out of Powell are still going to be clear water because the delta is still just forming somewhere upstream. And even when the reservoir drains to dead pool, you're then eroding all this and removing it down here. Highly likely the reservoir will still be clear. All right. Will the flow regime be reestablished if you partially drain the reservoir? Well, it might run of the river if you wished it would, but once the reservoir goes below minimum power pool, then you're locked in by the capacity of the river outlets. And the river outlets can only release 15,000 cubic feet per second if the reservoir has significant head above those river outlets. As the reservoir goes from minimum power pool to dead pool, the capacity of the river outlets plummets such that when the river is at dead pool, the capacity of the river outlets is less than 5,000 cubic feet per second. That in no way is the natural regime of the river. And so we modeled what would be the flow regime when the reservoir is below minimum power pool, what happens to the reservoir elevations. And the point is this: you can't maintain the reservoir at at those low stages because you're limited by the ability to get rid of the water downstream. And so PAL is actually fluctuating up and down all the time because you can only get so much water through, and only when the reservoir gets above minimum power pool can you actually have a 45,000 flood, because you're up there for a little bit, but you're trying to drain it, and it's a crazy flow regime, and no way is it natural. Okay, and the temperatures are going to be real screwy downstream. So let me just close with this. Okay, that's my analysis of this. Somebody had to do it. I didn't know well, here are some other issues that don't get talked about. And yet, we're talking here about renegotiating the interim shortage guidelines. We have to put the condition of the river ecosystems between the reservoirs on the table at the same time we talk about how we're going to reoperate the dams and reservoirs. Because the fact of the matter is, the amount of water that's released out of the dam is a primary determinant of the sediment mass balance of Grand Canyon, the stability of sandbars, whether or not you're going to have sandbars. The temperature of the water is controlled by the elevation of the reservoir and how fast the water moves downstream. Now we are getting to think it's the phosphorus, and that the system is phosphorus limited, and that's all related to mobilizing water and sediment. And and what do we do now in our negotiations? We talk about the river as a political entity, as if there's something at Lee's Ferry that matters. Okay? It doesn't matter. This ditch, with its two reservoirs on either side, is the bottleneck in the system, separating the land where the water comes from to the land where a lot of the water goes. And the way we proceed with environmental discussions is to say the lawyers and the engineers and everybody with power is going to negotiate and cut the deals on water supply. And once the deals are cut, then you say to the river scientists, oh, what's going to happen? That can't be the way we go. We have to be able to optimize water supply and environmental rehabilitation in the same discussion. So, the volume of releases matters for a whole bunch of things. We need to put this on the table. Even though there's about 700,000 acre-feet of water that comes in between Powell and Meade, we have to consider this an entirety. I would submit that even in the discussion that went on first thing this morning, where we talked about shepherding water to Lake Powell, that can't be the discussion. It has to be shepherding water to the southern Colorado Plateau reservoirs, and then we need to ask what is the best way to store that water and move that water through so that we don't consider this section of the river as just a pretty ditch, but we begin to talk about how do we manage water for supply to also benefit and rehabilitate that ecosystem. The Phil Meade First proposal is unlikely to reestablish a natural flow regime. The releases are going to be devoid of sediment. Doesn't look like there's going to be any change in reservoir losses if you preferentially store water in one reservoir rather than the other. The available data indicates a loss of water into the Navajo sandstone may be much less than GCI asserts. But now is the time to start measuring evaporation at Lake Powell. It's crazy that we don't have numbers any more recent than 40 years ago. And it's crazy that we don't have new groundwater modeling studies where we understand what the seepage losses are. And I would assert that when it comes time to renegotiate the interim surplus guidelines, river scientists are at the table. They're not an afterthought. Thanks.
Thank you, Jack. That was excellent. And I don't know what you picked up in my body language. I was just sitting there, minding my own business. I've never heard you refer to the Grand Canyon as a scenic ditch before. That's interesting. But it is a scenic. All right, next up is Mike Trolopoulos. I always say that wrong, and I probably said it wrong that time, who has his own law practice now, having worked for many years across the street that way at Western Resource Advocates. Mike, I believe, is the third person on the program who is a graduate of this law school. But beyond those details, I really don't know a lot about Mike. So I did the Google thing. You weren't here yesterday, but I've been Googling the folks to learn more about our speakers. Allegedly, according to Google, you're a hell of a soccer player. And according to our bio, you got a great Indiana Jones hat. But so those are two more things I've learned. Mike's on the program today because he and his colleagues have challenged me and others with a simple question, but a thorny question, and that is it really possible to pursue sustainable management of the system while still pursuing new diversions, new depletions throughout the system? It's a very good question. So, Mike, take it away.
Thanks, Doug. Honored to be here. Honored to be on this panel. In law school, I studied public lands and water law under Charles Wilkinson. Larry McDonald taught me oil and gas law. One class outside the law school was water policy with Chuck Howe, Indian law with Richard Collins, and environmental advanced Indian and international environmental with David Getches, who I'll refer to in just a minute. I'm not a water law expert. I'm not immersed. And I think being an outsider is a little bit of an advantage here in some ways. I'm going to try and channel some Bernard DeVoto and take a look at existing assumptions and institutions from what Bernard called an uneasy chair. So the question is, can we achieve sustainability while pursuing new depletions? The answer depends whether we think we're on the right track currently or we need to start rowing upstream against the current to get ourselves where we need to be. My theme is less is more, that less has always been more when it comes to water in desert civilizations, that if we don't get used to embracing droughts, native species, and healthy rivers, more is going to amount to a whole lot less for those of us who live here because we're in awe of the scenery and we want to create a society that matches it. And that's all of us. And that's the thing. 50 years ago, we were different. Today, the sons and daughters of the farmers are out there on their stand-up paddleboards in the water parks with the tech geeks from the brew pub and the internet cowboys, right? So I'm going to channel some legal scholars, touch on proposals for new development on the Upper Colorado, and offer some food for thought. And the first legal scholar I found in 1997, Colorado River Governance Law Review by David Getches. The Colorado is one of the world's great rivers, but no one holds a vision of what the river can or must be for the future. The purpose of the federal projects was that federal subsidies for irrigation in the Colorado River Basin led to increased cultivation of marginal lands that otherwise would have had little or no agricultural output. You know, think about it. It was true then, it's true today. Will it be true tomorrow? On equity, said water should be distributed fairly and in the broad interest of the public. Broad interest of the public. Do our existing institutions, prior appropriation doctrine, going back to the 19th century and the compact that's 100 years old, does it do that? On environmental and recreational interests, Professor Getches, Dean Getches, flora and fauna have been altered by development of the land, depletion of the river's flow, destruction of its natural systems. Water no longer reaches the mouth, which is a sprawling, eerie wasteland. The losses were foreseeable. Naturalists and environmental activists warned of them, as they're warning of them today if we keep developing like we did in the past. Ecological sustainability connects long-term human survival with ecological health. The federal government pursued development of the Colorado single-mindedly without anticipating or accounting for the consequences. The result is a river incapable of sustaining native fish species throughout much of its reach, a river so depleted that it has rearranged the natural landscape and everything that depends on it. The results of management under this regime have been unsatisfactory when measured against standards of economic efficiency, equity, and ecological sustainability. Another legal scholar, retired Colorado Supreme Court Justice Hobbs. A river can be killed by treating it only as a commodity rather than the habitat of life itself. This is Justice Hobbs. When we nurture our singing and working rivers, we celebrate the greater community in which we live. We understand that water rights do not carry with them a right to pollute a stream or choke its course to extinction. Pools, riffles, runs, meanders, cover, insects, fish, clean water to serve ag, drinking, rec, and fisheries. This picture of a restored Western river is becoming for us a basic lesson in Western physics, Western civics. And I was here for most of the day yesterday. When I walked in, we heard the governor from Gila River. What I wrote down, he was saying willows, cattails, close your eyes and you can hear the birds. It's an amazing thing. It touches the hearts. So I'll go real quick through the slideshow. Sustainability for me, Mike's Urban Dictionary, common sense. All right. And it starts with what's a healthy river, and I'm deferring to the scholars that I quoted from. Colorado River Research Group has a great quote here: comprehensive restoration requiring cultivation of a basin scale vision and strategy. And I'm not sure we're there. A lot of folks are talking about it. I'm not sure we're there. I think we can tweak what we've got to get there, and we have to do it. They're talking about sound science, a basin scale environmental vision articulated by the public. Not the public of 150 years ago or the public of 100 or 50 years ago, but the public of today. We need to update how we manage this river. We need a game plan. And, just a few things on the vision. I think Justice Hobbs and the other scholars I read from get at this. Emphasis on evolving, keeping up with where we're at today. I like this one because it kind of puts it all together, right? Stand-up paddleboards, that might be that water park in Glenwood, I'm not sure, with the coal train going by. You got the future and the past up there on the river, right? And David Getch's, this is real stuff, right? We've got a World Heritage area that what we do on the upper basin, so goes that World Heritage area that we're talking about. National Geographic, the state of the river. One of the things I want to touch on just briefly is that the river's not doing great. One of the most contested, recreated upon, and carefully controlled rivers on Earth. And let's be honest, recreation, we need to look at recreation also when we figure out how to best manage this river. But National Geo is telling us we've got a lot of challenges. We all know that. This just kind of takes out some of what National Geo was saying. More science on the river. We don't know it all. We don't have it all figured out yet. Major Colorado River Headwaters Research Study Project. Science is good. Independent science is better. I did a lot of oil and gas law. So it's great that the scientists are looking at the river, right? And I think the question I'm trying to raise here is the decisions we're making today and in the next 10 years, our kids are going to look back and say, what were you doing? 15 years ago when I started WRA, I forget the number, but 30, 40, 50 coal plants were proposed in the Southwest in this same area. Anybody tell me how many of those got built? Bagel, right? One bar? Expansion. No new coal plants were built. I'm saying, can we do that on the dams and diversions? pinch hitting for Gary Wagner here, Save the Colorado. Gary's at the River Keepers Project. And, you know, we're saying is when you're in a hole, stop digging. I like the skinny dip here. That's pretty good cross-marketing, right? You know, Save the Colorado is saying the river quenches our thirst, feeds our souls, enlivens our senses. And let's manage it for the ecosystem as well. I think Mr. Beard, former BUREC commissioner, is on Gary's board at Save the Colorado. And let's harness that momentum towards dam removal, and let's do it one better by not building any new ones. And when I was at WRA, I was doing oil and gas for the most part, a little bit oil shale. And, you know, some similar questions and parallels. And when the international press came to the Rocky Mountains to look at our oil and gas boom in the Bush administration, the first thing they'd say would always be, in an ever-increasing search to feed its addiction to fossil fuels, here's the footprint of oil and gas and fossil fuel development in the West. And I think the theme here is you got to address what's going on. Maybe we're a little bit addicted to cheap, sometimes free water, right? There's a lot of new dams. You know, I don't have some great charts. What I found interesting, Doug, was there's not a whole lot of great information out there in one place on all the upper basin proposals. And the numbers range from, Gary had a number, State of Colorado, I think 260,000 acre feet. I've got another source in here that was around 400,000. Gary says you can double if you look at Flaming Gorge, but quite a bit. And we heard from Eric, we're at 4 or 4.5. Saying let's keep it there. What would be great is we have a whole lot more rights on the river, and they're senior, not leftover, in-stream flow, non-consumptive rights. That's where we should be headed, right? Yeah, Colorado River Connected said 400,000 acre feet. They quoted the great John Wesley Powell, similar to what David Getches was saying in 1997. Only a small portion can be irrigated. I tell you, gentlemen, you are piling up a heritage of conflict. And the gentleman did it, and it's up to us to figure out what to do with it. I say we gotta fight. I say I don't have the slide. If I had more time, Brad, I'd have the slide of the person roped to the tracks. You got to fight to get unbound. We're about to get run over by that train in terms of the river. We all know we've got endangered fish. This one's the greenback lineage, cutthroat trout. We can go with restoration or the way of the bison herds. Got a few case studies here. I just want to go through them real quick. One is the Gila diversion in New Mexico above the tribal land in Arizona. Some of the issues are endangered species. This is only a sampling of the ones that are present there. And the Nature Conservancy convened 45 scientists to look at what would happen if this dam and diversion went through, and it may or may not be on track. I don't know if it's going to happen or not, but I think the larger point here is you got a stream, a tributary, one of our great western rivers like the Yampa or the Gila that isn't dammed in 2017. We're going to look our kids and our grandkids in the eye and say we let that free-flowing river get dammed on our watch because we needed more stuff. We were so addicted to that cheap free water, and that we weren't willing to revisit where we were. So, yeah, TMC's got some silence on the Gila. There is a real interesting, I don't know quite how this works. I got it from a colleague, a legal colleague, who's looking at that for, I believe, the Center for Biodiversity. The Water Resources Planning Act from 1965 that's been amended a couple of times, resulting in principles, requirements, and guidelines that are kind of basin-wide criteria and studies that we needed. One of the points David Getches made in his law review was that almost all the dams on the upper Colorado and the entire system were built before NEPA. Take a look at this frog here. Throw him in the pot. Water you just dipped it up from a bucket out of the stream running past the cabin. He's okay. 50 degrees, 60 degrees, 7 degrees. He's still okay. All right. That's what's happened to the basin, because you look at these new projects today, it's only going to be 18,000 acre feet here. Wyoming, 8,000 acre feet here, Fontenelle, Big Piney, whatever it is. They're incremental. We're looking at one project, but sooner or later, it's going to be that piece of straw that breaks the camel's back. That frog's going to get cooked, right? If we keep approving these projects and we're not looking at the big picture to this day. I've got a lot of slides on Moffett in Colorado. It's a nice one we started off with. Water law here. Left-hand ditch was the first case we read. Is it left-hand ditch? Help me out. It's right up there outside Netherlands. So Moffett is diverting water from the Colorado headwaters south of Rocky Mountain National Park to Denver Waters North System through South Boulder Creek, which is my creek I've lived on for most of the last 25 years. And it's bad for the headwaters that are already seriously diverted. You can see the hydrograph, historic, original Moffett project, and we'd be going down to 10 to 20% of natural flows during the peak runoff period, the flushing flows. That's the hydrograph showing how low those flows are when they would be diverting. I want to compliment Denver Water. They've done a kick-ass job since Two Forks got vetoed by a Republican EPA administrator in 1991, I believe, William Riley. I'm not sure. For me, what's the lesson of Two Forks? What's the lesson of Two Forks? If we didn't have that water, we were going to go dry. Metro Denver was going to dry up. Nobody was going to be able to build anything. We weren't going to be able, Colorado was going to go backwards as a state, right? These are Denver Water billboards. Denver Water has done so damn good at conserving. It's a success story, and it boils down to, we're saying, let's do more of it. Let's double down on conservation because it's working, and that's what the population wants, and that's what the river needs. In terms of the findings, according to the FEIS, this isn't me or my clients or our consultants, the FEIS experts found you've got fisheries in at least 10 streams collapsed or near collapsed. Fish populations, 15 tribs that are past, near, or on the brink of ecological collapse before we take out another 15 to 18,000 acre feet a year. And this one goes to nutrients, the fundamentals, the base of the food chain, like the grasses in the savanna. 70% of mayfly species, this isn't on the exact same stretches of stream. It might be on a different stretch of the upper Colorado, but it's relevant data. Mayflies are down, stoneflies are down, species missing. And, the quote here is, I've got a Hubert Humphrey quote. Save the Colorado talks about the Colorado from the source to the sea. The moral test of government is how that government treats those who are in the dawn of life. The children, those who are in the twilight of life, the elderly, those who are in the shadows of life, the sick, the needy, and the handicapped. So if you're talking about a river, the source is the children, the headwaters. The sea, going into the sea, is the elderly. And the ill and the needy, that's our tributaries, our ailing tributaries and the suffering stretches of the mainstream of the Colorado. I'll skip over the energy development, but the point is a lot of what Utah and Wyoming are talking about in the oil shale threat could use unbelievable amounts of water. BLM projections, according to this report, up to 378,000 acre feet for oil shale, the most climate toxic, destroying fossil fuel left in the ground. There's a reason it hasn't been produced up to now. Let me just try and sum it up here. When Bill Ritter got elected governor, we tweaked the organic statute for oil and gas. In the state of Colorado, it was about 100 years old, went back to the 1920s, and we tweaked the definition of waste and in the statutory definition of waste that resulted in a 2016 Colorado Court of Appeals opinion that oil and gas operations must be conducted a mandate for protection of health, safety, and the environment including wildlife resources. Because we looked at the law, I was brand new to state oil and gas law. We read it, we said this definition of waste is the issue. So we changed a few words. We passed 2 bills through the State House in 2007, almost unanimous support, industry non-opposition or affirmative support for the Colorado Habitat Stewardship Act. What I'm trying to say, if the oil and gas and the coal lords of yesteryear, to channel Professor Wilkinson, can adjust to a new era on the energy front, can the prior appropriation water buffalo lords of yesteryear be open reforms that usher in a new era in water management? If we pretend the legal and policy framework just needs more communication and collaborative effort, it's unlikely we'll make more than marginal incremental progress on the values and concerns raised by David Getches 20 years ago. Things could continue to get worse before they get better, and we could misallocate billions of dollars on a worldview more in tune with Wallace Stegner's lands of Gilpin and the Chinatown Syndrome than John Wesley Powell, First Nations, and eco-decoupling. And the last thought I'll leave you with, in the last 20 years, here in the region in the Southwest, Colorado River Basin, we've made incremental progress, significant but incremental progress on some of the big issues like energy, climate, and water. And the challenge I'm throwing out there is let's be like the rock climbers in Yosemite, the guy who just scaled a wall without ropes in 4 hours when it used to take 4 weeks. Let's be like the kayakers and the speed runners in the Grand Canyon and keep pushing the limits of the possible. Let's make the unattainable seem mundane, like herons, Jennifer Pitt swooping over deep water in the Delta, maybe even the Salton Sea, Mike Cohen, and headwaters of the Colorado thick with native cuts.
Thank you, Mike. All right. Our last speaker in this session is Daryl Vigil, in the dreaded last speaker before lunch slot. Daryl's the water administrator for the Hickory Apache Nation and is the chairman of the 10 Tribes Partnership. And I first met Daryl 3 or 4 years ago at the Cairo party. And I'm just curious of how many people know what that means. Okay. This is a gathering in Vegas that happens every year in conjunction with the Colorado River Water Users Association meeting. And it reminds me of that, you know, in business, deals happen on golf courses, and in the Colorado, things sometimes happen at the Cairo party. So for a couple of years now, Daryl and the 10 Tribes Partnership has been working with Reclamation on a tribal water study that I expected to be old news by the time that this conference came around. But like everything else we've discussed, the schedule has slipped a bit. So that will be, I'm sure, a big part of what Daryl can talk to us about. So,
Great.
Yeah.
Good morning, or is it still morning? Yeah. Good morning, everybody. Thanks, Doug. I appreciate the invite to speak today. It's always an honor, you know, to get to, talk about, what has become my passion. You know, in a former life, I was opened 2 casinos for my tribe and spent about 20 years in the hospitality industry in a hotel, restaurant, bar that my family owned on the reservation. So starting in 2007, when I became the tribe's water administrator, I was, all pun intended, took a swim in this whole new era, or took a plunge in it. And it's been, an incredible experience for me, and like I said, an honor. I really appreciate just listening again this morning to the previous speakers on my particular panel, because I think part of the thing that, has really broadened my mind is just the incredible passion that people have for the Colorado River Basin. And I always enjoy learning something new. And so I appreciate that. I'm my tribal affiliation is Hickory Apache, and I'm also part Zia Pueblo and part Jemez Pueblo. And so, when we talk about Anasazis, I think, my people have been dealing with climate change for thousands of years. And I think based on Chaco Canyon, we can attest that it is for real. And so I think, it's something that, and a lot of those same lines, I think, tribes in general in the Colorado River Basin and kind of the newness of tribal settlements and decrees with tribes are fairly new. And so I think, being kind of the new guys to the policy table and the whole discussion about water in the Colorado River Basin has been, really, really interesting, because tribes in general have been a reaction to a large extent to policy, because we are newcomers to the policy table. But when we take a look at, the potential impact of tribal water in the basin, you have, of the 10 Tribes Partnership alone, you have close to 3 million acre-feet of water rights in the upper and lower basin, 20% of the volume of the river. Substantial. And, I think because of our newness, we weren't traditionally at the policy table. And I think I'd like to talk about this quite a bit, in terms of my experience of tribes in discussions about about water in the Colorado River Basin being the elephant in the room. I remember my first Colorado River Water Users Association conference, and just how, there seemed to be a huge disconnect between the stakeholders that were in the room and the tribes. And it's something, coming from the business background, that I was like, what? This doesn't seem that complicated to me. But, why aren't these guys talking to those guys? Why are we sitting over here? And, but I really, really appreciate it, those people in this room, who understood, kind of the unique nature of tribes. And it's something that I think that we as the 10 Tribes Partnership have really, really, really tried to address over the last, specifically 5 years. And part of the issue is that there are 567 federally recognized tribes in the United States. Each one separate and unique sovereign entities in their language, their culture, their geographic areas, and their practices. And so, that there's, from the get-go, there's like, okay, there's an issue, because how do you deal with that? I had a really, really close friend of my father's that used to be the executive director of the Council of Energy Resource Tribes. And he always used to say, if you know one Indian tribe, you know one Indian tribe. And so, and that's kind of at the heart of it, because I think in the past, there's been this kind of like collective thought from my opinion of like, oh, we need to deal with them in this way. But even within the 10 tribes alone, the nuances and the distinct differences of our settlements and our decrees, are absolutely different. And the languages and the practices and the nuances of those settlements are different, and the way that tribes want to develop their water are different. And so how is it that, you can actually herd that and build consensus and align on certain issues? And so, for the last 5 years, we've been really trying to accomplish that and realize that, although we are sovereign entities and we're distinct, that we don't live in a vacuum. We live in a broader world. And being a part of that broader world isn't, I think the traditional kind of political practice of tribes has been, pounding the fist and it's your responsibility, Bureau of Reclamation, federal government, to look over us and to watch out for what is best for us. And that, instead of us maybe taking the lead in that. And so we've really tried to shift that and not to be under any kind of delusion that somebody's going to do it for us, but really try to take the lead in how that might look going into the future, especially accounting for the fact that, you're talking about 20% of the volume of the river. And so as we move on, and my experience of Colorado River water and the law of the river, has been all pretty new to me. And so how is it that, moving this partnership forward, that we actually start to take a look at, how we become a part of this process? And one of the things that we've actively tried to do over the last 5 years is really try to do, and it's part of our mission statement, and it's part of our vision statement, are to create some sense of relatedness to the rest of the stakeholders in the basin. And I think, that's something that, that we're going to continue to do, because it is part of our vision and a part of our mission statement to continue to do that in terms of educating, the non-tribal stakeholders in the basin exactly who we are, what we're up to, and what's important to us. Because I think that's something that hasn't happened historically in terms of, this is who we are. We're not going anywhere. We've been here for thousands of years, or we've been here since time immemorial. And so what is it that, that we can lend to this whole process in terms of, I think I heard it earlier, common sense solutions. And something that I'm very, very interested in, because, I see, a lot of, I love the saying, our best thinking got us to where we're at today. And so what is it that, that we can bring to the table that's unique and distinct in terms of, where the Colorado River is going? And I think one of the things that, I'll go through these really quickly. Our partnership was formed in 1992, and really to just, keep up to date. The leadership at that particular time, I think, was pretty insightful in terms of forming this organization. And I think we're pretty unique in terms of any tribal organization, or maybe any organization in general, in terms of our ability to create consensus and align and create an agenda. Because there are such unique nuances to each tribe. And then we joined CRUA in 1996. There's upper basin tribes and there's lower basin tribes. Upper basin tribes include Northern Ute, or the Ute tribe, Ute Mountain tribe, Southern Ute Indian tribe, Hickory Apache Nation, and then the Navajo Nation actually sits in both basins. And then on down the river, we have Fort Mojave, Colorado River Indian tribes, Keyshawn, Kokopah, and I think I got them all, and Chemehuevi. And so, we've been very, very active in terms of a recognition of who we are and our settled water rights and those decrees as well. As you can see, geographically pretty diverse, and way up north in Utah, we don't have any tribes in Wyoming, but, Colorado, Utah, New Mexico, and then on down the river. And then one of the things that, always comes to mind when I see this map is the Keyshawn and Kokopah, because we did a film for the CRUA conference where we highlighted, we're trying to create, in our efforts to create relatedness, where we talk about, I think it was a leader from Kokopah, where he talks about that they're a river people and their whole life is given by who they are as a river people. And the camera pans to the river and there's no river. And so it's like, well, you take away a people's identity and their ability to be who they are ongoingly. And so at that particular moment, it became, at both times became really angry and really, really sad at the same time, in terms of, talk about endangered species of fish and whatnot, but, you talk about the indigenous population of the United States, to some extent or another being endangered. And so how is it that, we can continue to get ahead of that? Because we talk a whole lot about the ignorance in terms of each tribe or Native Americans being considered an ethnic group rather than distinct sovereign entities. And how is it that we can continue to get that messaging across, to the broader basin and those stakeholders about what it is and what's important to us? And so we created this vision statement. I think it's really, really powerful. And so I don't have much time, but I'll read it. Water is life. Water is the giver, the sustainer of life. Water is a sacred and spiritual element of the tribes of the partnership. The Creator instilled in the first peoples the responsibility of protecting the delicate, beautiful balance of Mother Earth for the benefit of all living creatures. The partnership well embraced and owns stewardship of the Colorado River and lead from a spiritual mandate to ensure that this sacred water will always be protected and be available and sufficient for each tribe's homeland. So really taking that on as a group of 10 tribes, the leaderships, this went to the tribal councils to embrace and to adopt this vision statement because, that's the context from which we wanted to operate from. That spiritual mandate. And to me, that's the most powerful context to operate from. And then our mission statement. It's been talked a whole lot about, that I heard this morning in terms of, the common agendas that we have. And one of our efforts is, again, to collaborate and to build partnerships. And so part of the mission statement, talks about the consult, collaborate, coordinate, and to educate. And because we see that as one of our primary objectives in terms of us getting to be, for you to get into our world so you can know what's important to us, so hopefully we can have jointly created solutions. And so, in 2012, the big basin study was completed, or in 2009 it started. And one of the biggest things that would happen with that was, and we beat up Bureau of Reclamation and Department of Interior and our federal friends at length, Terry Fulp, Larry Wakowiak, where are you, about our exclusion from the study. And we thought that it was unconscionable as, we have 20% of the volume of water in the river, how we could not be a part of that discussion. And, we had some really, really good things come out of that. And it was really a call to arms for the partnership in terms of our participation in the dialogue, not just waiting for something to happen or somebody to do something for us. And so out of that conversation, out of that exclusion, really came a dialogue about, well, no, we really need to have some acknowledgement, and there needs to be some education in terms of, what is the impact of tribal water in the system. And we really got to see that the broader basin study I don't think it was really designed to do that, and it didn't really adequately capture it. So there was some disclaimer language that the partnership developed, that said that it didn't adequately capture it. And that was the first step of that whole process for us that led to the discussion of the tribal water study. And I really, really appreciate, those people that helped and that understood that, namely Ann Castle, thank you, Ann, and Mike Connor, and I think to a large extent, Sally Jewell and Secretary Salazar as well. They were all critical in understanding that. And I think part of that whole process with Bureau of Reclamation, I have to acknowledge, Carly Jurla, because she's the one who came out specifically to the reservations where she got it. She understood, by coming out to each reservation that we were unique and distinct, and you couldn't just lump us all into one thing, and there was going to be a need to further, evaluate the impact of tribal water in the system. Now, I know that's a little fuzzy, but I think that's, this document becomes really critical because, I really, really did appreciate then Assistant Secretary Castle's efforts in finding money and creating the structure and the mechanisms to empower a separate tribal water study. And it really talks about, there again, tribes having what the tribes have and how and what we want to do with the recognition of our tribal water rights. And so that happened in Albuquerque, the signing. My hair was darker then. And it shows you what happens when you're in water policy, your hair gets grayer. And so what are the objectives? Again, to assess the current future water development of tribes in the partnership. And so it's been an active, ongoing process for us and in our partnership with Bureau of Reclamation. and to really see, you know, some of the things that have been interesting to me in going through this process is, and with a larger study, is how, you know, the distinct groups, you know, you have the municipal groups, you got the environmental groups, you got the tribal groups, you know, you have, and you have our federal partners, how sometimes they really don't talk to each other to a whole lot of it, to a large extent, and how, you know, this process is really not only forced us, but it's because we want to, we have a desire to create those partnerships that haven't existed before. And because we do have overlapping agendas, and it's like, why haven't we ever utilized those? You know, why haven't we ever talked to the Audubon Society? Why haven't we talked to the Nature Conservancy? Why haven't we talked to municipalities or state governments about what is important to us? It's always this contentious protect, defend kind of environment, you know, which keeps us where we're at. And so, you know, we really are looking at the tribal water study as a huge opportunity, not only for the tribes, but I think for the basin in general. And so, you know, it looks at current usage, past usage, current usage, and future scenarios. And some of the results are have been pretty interesting up to this point in time. And each one of the subsection of the tribal water study it deals with each tribe, and each tribe has a different storyline about how they look at their, you know, their water from a historical and cultural perspective. And so I hope, you know, when it rolls out, we're going to do a big rollout. We're still planning on how that's going to look, but, you know, we're really excited about, you know, the messaging that it's going to get to the broader basin. And so some of the opportunities that we see out of this, you know, because, you know, our settlements and the decrees are really different, you know, we really hope to, you know, what are those opportunities that we see? And these are some of them, you know, and when we look at these opportunities, I think one of the things that's happened in the past is that there's been a fear of, you know, well, what are tribes going to do? Or what are they not going to do? And we really want to be really transparent in terms of, you know, tribes in general want to put their full allocations to use on the reservations. But if they can't, you know, because of those barriers and those challenges, whether they be money or because of policy or law, what is it that we can do to partner with each other to actually, you know, be able to address those common issues that we have? And so what are the next steps for us? You know, we had hoped to roll this out at CRUA in 2017, but we're hoping that it'll be in the end of August. And so, and then, you know, after that point in time, you know, we hope to really spend the time to get it to different conferences, to our congressional delegations, to our state delegations, and to anybody who will listen to us, you know, in terms of being able to share the results of the tribal water study. And so I think, you know, as we move on, you know, you know, we're committed to the process of collaboration and forging those partnerships that maybe didn't exist before. And it didn't exist before for whatever reason, and I don't think it really matters. I mean, we can go back and beat up on, you know, why, you know, tribes maybe weren't included in it, but the important thing now is, you know, that we're gonna make the request that we have access to those things, because we think that we have a pivotal role to play, especially considering the context that we operate from in terms of, you know, what we want to see happen with the Colorado River. And it's really, really interesting that, you know, everything, you know, from what I've read and what I've heard from the other 10 tribes partnership, and I heard somebody mention a little bit about Governor Lewis this morning, because one of my passions is to talk about this across the nation. I've talked to the tribes on the East Coast, the Great Lakes, Oklahoma tribes, the tribes up north, the tribes in the Northwest, Southern California Tribal Chairmen's Association, Intertribal Council of Arizona and in Nevada. And the common thread is that, you know, water is at the heart of it, you know, for us. And we totally understand that, and we're committed to, because of how we look at water from a spiritual standpoint and the importance of it, that we take personal ownership of our role in creating solutions in terms of making sure that the river's there. And like it said in our vision statement, not only for humans, but all living creatures. Because that's one of the things that I think that's really pivotal in this whole process to us is getting across balance. To maintain that balance, not only in nature, but the human balance as well. And if that balance isn't there, then we know what's going to happen. I really appreciate your remarks about that, because we know it's going to be bad, or it's going to get worse. And so we really hope, and we know that the tribal water study, will hopefully be a tool not only for the tribes in terms of creating a roadmap of what we want to do, but that you can adopt it as well. And you can see that it would be important, for you and those communities that you live in as well, to have an understanding about tribal water settlements and about tribal decrees and about, the distinct nuances of each tribe. And so with that, I really thank you for your time this morning. And if anybody ever wants to come down to my reservation, Hickory Apache Nation, it's beautiful down there. And so we can show you, what we're up to in terms of our own water development. Open invitation. Thank you.
All right, fantastic, Daryl. As I had feared, we had more good material than would fit into the 90 minutes, and so we have started to bleed into the lunch period. So rather than have questions that whoever asks the questions would immediately be the enemy of everyone else in the room, because you know how that works. Rather than do that, I will say adjourn for lunch, but I will ask our 4 speakers to hang around a little bit. If you want to talk to them, ask them a question, come down, do it now. But for the rest of you, lunch as usual upstairs. Reconvene promptly at 1 o'clock. Thank you. And
That's great.
Thank you, Pam.
Thank you.
Good job, yeah. You just east of Farmington, right?
Yeah.
Yeah.
Yeah.